Good morning. Welcome to lecture 53. This is continuation of the previous hands-on exercise to know the effect of elevated CO2 and temperature on crop performance. So, lecture 52 we have done the exercise for the rice, how the CO2 and temperature modification can be done in experimental management file, and how to create the treatment combinations in the treatments and do the simulations for the rice crop, that we have shown for the rice crop. So, now we will be showing you the same the CO2 modification and temperature modifications and the effect on potato crop using the simulation of underground bulky storage organ substore potato. So, we have shown you Ceres rice model. In Ceres rice model, how we can do the modification of the environmental parameters in the experimental management files and create the treatments and do the simulations as you did earlier. So, here we will show you the same the change in environmental parameters on potato production, but here the treatments we are going bit different. Here the exercise 5, if you see this exercise 5 for the potato, using the N management 200 kg N per hectare and the water management automatic when required. In rice we did the water management as a rain-fed conditions, because rice is grown during monsoon season with the receipt of the monsoon rain. So, does not require the irrigations for this location, particularly when you get the sufficient rainfall to grow rice crop. Here we have to take the automatic when required. We have taken the earlier we have shown you the exercise automatic with the drip irrigation. So, we are using the automatic drip irrigations. N management 200 kg N per hectare, that is a previous exercise for the potato crop on exercise 3. The same information we will be using for this environmental modifications. Simulate potato yield for rising CO2 levels. So, 0 ppm, 100 ppm and 20 ppm, and the temperature 0 degree, 1 degree and 2 degree Celsius above ambient. For the planting date, we have chosen here the 20 November in 2014. So, this is a normal planting time, you can say that up to around 20 November, 15, 20 or 30 November. So, these are the planting window, normal planting window. So, we have chosen the one planting time 20 November 2014. So, write the T-bar yield for each treatment and give a suitable interpretation of the results. So, here so what the changes we are bringing in this norm, one is the environmental modifications, 3 CO2 levels and the 3 temperature rise, and the fixed we are putting the N management as a 200 kg per hectare and the water management irrigated. Your potato is grown during rabi seasons, this require the assured irrigation facility. So, when you are growing the crops, irrigation facility definitely available with us. So, we are using the irrigation as automatic and required irrigations. Yeah. So, here what we are doing, the crop is now potato, that is a model is substore potato, simulation of underground bulky storage organ, that is available in the DSAT model. The soil type we are using the sandy loam soils, planting date at 20 November in 2014, nitrogen level that is a 200 kg per hectare, and how the application nitrogen application, the source is urea broadcast and the incorporation in the depth of 10 centimeter. Nitrogen application 25% nitrogen at 1 day after planting and 50% nitrogen at 20 days after planting and rest 25% nitrogen at 40 days after planting. Water management, the automatic irrigations applied automatically when the crop requires water, at that when the water level goes below the threshold level, and the irrigation is applied to reach the soil moisture the 100% available. And these are the climate change we are making here on the carbon dioxide levels. So, we are adding the 0 ppm, that is ambient value we are taking, then the 100 ppm additions, then the 200 ppm addition CO2 levels. Temperature increase, that is 0 degree Celsius, 1 degree Celsius, 2 degree Celsius. These are the 3 into 3, you see there will be 9 treatment combinations. If you go to DSAT file, you can see you can open the DSAT file and then go for the potato comes under root crops. Select the crop potato, then go upon this experimental file, that is .ptx file you can open here. Then you can have the as you did for the rice, the fields, create the field entry, select soil type, the medium sandy loam you can select here, Then the planting date. So, go to management and click the planting and set the planting date as 20 November 2014 as per the exercise. Then nitrogen levels. So, again you can go to the management, click that fertilizer management, N levels, that is say 200 kg nitrogen per hectare, and also once you include the nitrogen 200 kg per hectare, you can select the application schedule, applying 40% of this 200 kg nitrogen at 1 day after planting, then 25% and that is 1 day after planting, and 50% that is 20 days after planting, and rest 25% at 40 days after planting. So, that split application you can specify in the model. Then the water management, you have go to simulation options. Since we are not going for the fixed amount of applications, we are going for the automatic. So, automatic is available in the simulation options. You can create one entry, that is automatic irrigation, that you can put there. Then climate factor. So, the environmental, you can go to environmental modification file for the changing the carbon dioxide level and temperature levels. So, go to environmental modification file, create 9 entries at temperature and CO2 level for each entry, as we have shown for the rice. As you did for the every CO2 and temperature, same entry you can create here. The similar way to rice crop, you can have the environmental modification file for the 9 treatment combinations. Once you do the environmental modification file, then go to the treatment window. So, in treatment, so create this 9 treatments, 3 CO2 level and 3 temperature. So, here all columns remain same, there is no change except the environmental modifications as per the entry. The label you can change in the treatment columns, where we have the environmental modifications, there you can change the labels that indicates the different CO2 levels and different temperature. Total 9 combinations will be there. Then you can save the files and the run simulations. So, here you can see here these are the treatment combinations as same as the for the previous rice experiment. You have the temperature increase of the 3 levels, 0 degree, 1 degree and 2 degree Celsius. CO2 increase also 3 levels, 0 ppm, 100 ppm, 20 ppm. So, these are the 9 treatment combinations, C0 T0, C100 T0, C200 T0 stands for the C0 as 0 degree increase in temperature, or C100 with 0 degree increase in temperature, C200 ppm with 0 degree increase in temperature. Similarly, the C0 T1, C0 T2, C100 T1, C100 T2, C200 T1, C200. So, different CO2 levels, different temperature, we have created the 9 treatment combinations, and these combinations you can do in your when you go to treatment. So, level descriptions. So, this 9 treatment combination modification can come here. Other everything remains same. Here this simulation control we have put 2, that is for the automated irrigations. I will show you, and this is the environmental modification. As you click this one, that can show C0 T0, C0 T1, accordingly you have put the 1, 2, 3, 9. So, once you do this environmental modifications, and then you can go for the simulations. After simulations, I will show you these are the graphical output. You can see the tops weight or total biomass that changes for the different CO2 and temperature, the minimum and the maximum biomass for different C200 T2 and the different C0 and the T1, or there some the C0 T. So, depending upon the environmental modification. So, these are the 9 treatment combinations, 9 lines represent the 9 treatments, where we have the tops weight. You see the grain weight, that you can say for this potato tuber weight, tuber fresh weight megagram per hectare. So, you can see tuber weight, the lowest tuber weight we get from the C0, and the temperature increases 2 degrees Celsius. With the rising temperature, no CO2 rise, that causes the significant reduction in the potato tuber yield. You can see the highest tuber yield, that is the carbon dioxide, the 200 ppm rise, temperature, ambient condition 0 degree Celsius, where you have got the highest potato tuber yield. So, with rise in CO2, there is a increasing the photosynthesis rate and the more biomass accumulations, and that increase the tuber formation, tuber bulking potato with the rising CO2 levels. but with the rise in temperature there is a loss in potato production, there is a adverse effect on the tuberations with the rising temperature, the same CO2 levels. So, these are the grain weight. So, what you can do when you go for interpretations, the overview output file will show you, when you run the model will show the overview output file for different if a C0 T0 already have shown how the temperature modification, nothing is given here as add 0 means. So, there is a ambient conditions, no change in the current environmental parameters. Accordingly, the potato, you can see potato, these are the potato models, and the you can find this these are the informations you have made a entry in this model. As per the information, you can find what are the nitrogen fertilizer 200 kg per hectare, 3 application, this information you can see here, and these are the overview output file, the different crop age and the simulation, what the biomass that you can see that you can find here, and these are the final simulations for the potato. When you present the data, particularly for the CO2 0 ppm increase 100 ppm and 20 ppm, and temperature increase 0, 1, 2 degree Celsius, these are the interaction table that shows the tuber yield at different CO2 levels and temperature. So, if this one is the ambient conditions C0 T0, when the ambient weather the yield is around 67 ton per hectare. As you go on increasing temperature, the yield goes on decreasing. Similarly, for the ambient temperature there is increase in CO2 levels, the yield also goes on increasing. CO2 has a positive effect on the crop yield. With increasing CO2 at the same temperature, the potato tuber formation or tuberation increases, there is a increasing tuber productions. Whereas, with the same CO2 levels, with the rising temperature, it has an adverse effect in potato tuber formation. With the rising temperature, the tuber yield goes on decreasing. So, this is what you can see the you have taken only 3 levels or the 3 levels, you can have n number of levels. You can increase the CO2 level to as a 0 ppm or 50 ppm, 100 ppm, 150, 200, 250, as many levels you can like, and also temperature you can increase the as many levels you wish to have. So, you can see the combination of different carbon dioxide temperature and see its effect on the potato tuber productions. So, what we will be showing you now, the same thing we have done in the DSAT models. So, now we will show you the environmental modification file as you have seen, and see the simulations and see the overview output, how this is done using the DSAT model software. So, now we can switch to the DSAT software. You can open the the DSAT software loaded in your computer. Yeah. So, this is a DSAT window. So, you can choose your crops, that is root crops. You can click the root crops, select the potato here, and these are the experiments available. So, for our purpose ITKG 1401.ptx. So, that file you can edit that file, potato file. So, here if you can go to environment and the fields, already you have the same site, you can go to fields, the soil type sandy loam. So, already you have shown this one for rice crop, the soil remains sandy loam data, and the soil profile IT 00020/2 and weather data also ITKG 2014 weather data is there. So, this same as the previous. Then go to environment initial conditions. So, here you can find the measurement date. So, you have given 15/11 we are planting, we are doing 2011. So, 15/11 the measurement dates, and the previous crop was rice crop here, rice crop. So, that is root 500 kg per hectare, and there is a 100% incorporations in the soil. You see the profile. So, profile. So, based upon profile already you have calculated based on water available, already there is no need to change this one. Then you can see the environmental, you can click OK. After that you can click OK, go to the environmental modification. Here already you have done earlier. So, this data already entered for the C0 T0. You can see the carbon dioxide, the 0 ppm added and temperature 0. Similarly, C0 T1 carbon dioxide 0 ppm added, temperature 1 and 1 degree Celsius. Similarly, C0 T2 0 CO2 and temperature 2 and 2 degree Celsius. then C100 T0, CO2 added 100 ppm, temperature 0. Similarly, C100 T1, carbon dioxide 100 ppm, temperature 1 and 1 degree Celsius. The next C100 T2, carbon dioxide added 100 ppm, temperature 2 degree Celsius. Next C200 T0, carbon dioxide added 200 ppm, temperature 0 and 0 degree Celsius. Next C200 T1, carbon dioxide 200 ppm, temperature 1 and 1 degree Celsius. Next C200 T2, carbon dioxide 200 ppm, temperature 2 and 2 degree Celsius. So, these are the environmental modifications we have done already, and then you can see the treatment, go to the treatment simulation options. If you see simulation options, we are going for the automated irrigations. So, you can choose the level 2, that is a automated when required. If you go to management, here the planting on reported dates, irrigation and water management, the automatic when required. So, that you can give the, so you also you have given the drip, you are the trickle irrigation. So, method of irrigation given drip irrigations. So, rest treatment fertilizer on reported dates, you can see the fertilizer on days after planting, and the organic amendments no applications, harvest at maturity. So, these are the information given. Once you have done the simulation options, go to treatments. So, here the as per the descriptions, already you have put the descriptions. So, all the columns remain same except the environmental modifications, where I have put the C0 T0 for the level 1, then C0 T1 for level 2. Accordingly, the up to 9 treatments has been put as per the description here, that matches with the environmental modifications. That is for the environmental modification. Then if you see the simulation control, we have put for the automatic when required. This is level 2. So, all the cases that remain same, then you can press OK. Then you can save the file, close this window, go to refresh, then you can click that experiment, run the model, press OK, then go for analysis. You can click the plant draw out, plot it. So, here you can choose the any top weight, you can choose the top weight, select all runs, then next. So, the figure we have shown you. So, you can see the different treatments. So, I give the time series, that is a biomass, the top weight, how changes for the C0 for different carbon dioxide level, there is no change in carbon dioxide temperature, increase, that gives the lowest biomass. Similarly, for different CO2 and temperature, you can find the biomass line 9 treatment shows 9 lines. If you go back and click the tuber weight, the tuber fresh weight, here potato, you have the tuber fresh weight and tuber dry weight. So, if you put the tuber fresh weight and the select next, so you can see the yield levels, how the tuber yield changes. The lowest yield is there, the carbon dioxide level 0, temperature and T2, the rising temperature 2 degree Celsius with the 0 ppm rise in CO2, that causes the severe reduction in grain yield to the high rising temperature. But whereas there is no rise in temperature with rise in CO2 levels, that gives the maximum potato tuber production, that is C200 and T0. So, this is the grain weight. If you go back, you can see also the tuber dry weight. You can click the tuber dry weight, also click next. That will give the similar trend as of the tuber fresh weight. So, only because the moisture is removed, only dry weight is given. So, the yield levels after the extraction of moisture, what is the dry biomass, that is given the tuber dry weight, that is same pattern as of the tuber fresh weight. So, you can go back, and here if you wish to see the different parameters, no, you can have there are many as per the water level or the nitrogen level. So, these are the different variables are there as per the wish, as per their interest. You can click and you can highlight and you can make the figure, and you can get the data also. Data can be exported to Excel file. Now, we can go to show you the overview output file. So, these are the graphical presentation. We can close this window. We can go to overview output. See, click the overview out, then view, as we have shown the earlier exercise for the rice crop. Here you can see this is the for the potato, this is C0 T0. For this case, if see environmental modification what you have done. So, there is a all cases. So, you are not added anything. So, addition is 0 for all the parameters, and you can see the yield yield levels as per the simulation as shown for you have seen for the rice crop. Similarly, here the potato for the different growth stages, and the final tuber yield you can find here for the C0 T0. So, ambient conditions without change in carbon dioxide, without change in temperature, for the normal weathers and the normal recommended practice, this is the yield you can get. So, if you go to next run, so where we have got the carbon dioxide levels 0, but temperature rising 1 degree Celsius. If you see the next run, the C0 T1, where this is the CO2 levels, there is no rise in CO2 levels, but there is rise in temperature by 1 degree Celsius. Here you can see the temperature modifications, the addition given 1 and 1 here, but the carbon dioxide addition remains 0. CO2 is there is no change in the carbon dioxide content or the additional carbon dioxide. Accordingly, we can see the yield data, see the stage wise the biomass simulations and the final yield data, that is with the rise in temperature as compared to earlier yield, this is the lower yield. So, the yield is decreasing with the increasing in temperature. Similarly, if you see the go for to C0 and T2, there is a 2 degree rise in temperature. So, this is the C0 and T2, where the carbon dioxide there is no increase in carbon dioxide, but temperature increases at 2 degrees Celsius in T max additions and the T min additions. We have shown here the 2 degree and 2 degree, and carbon dioxide 0. So, here you can see the yield is lower, will be lower than the previous value, whatever yield we have got, this will be still the lower value, this is 58.53. So, there is a decreasing yield with the increasing temperature. When there is a rise in temperature, the yield gets reduced. So, similarly, if you go to the other one, the C200 temperature 0, see carbon dioxide increases by 200 ppm, but temperature 0 degree Celsius. And see the C200 T0, and if you see the environmental modification file, where you have seen carbon dioxide level is increasing by 200 ppm, but temperature addition T max or the T min, that is 0 degree 0 degree. In this case, you will find the maximum yield. If you go to the yield value, you can find the yield is here 78 I think 6 kg per hectare. So, this gives no information. There is a as per the increasing CO2 at the same temperature, there is rising CO2 levels that enhances the tuber formation of the tuber productions, but at the same CO2 levels the rise in temperature that has a adverse effect on the potato tuber productions. So, the point we are mentioning here. So, this type of the environmental modification you can create in the environmental the experimental management files. So, we are doing for the carbon dioxide temperature T max and T min. So, you can do for the rainfall, such the rainfall variability, or we can do for the solar radiation, the solar radiation variability, or we can do the wind velocity. So, these changes can be made, and accordingly the information can be created in the treatment window, where you can put the information as per the environmental modification you have created, and this you can go for the simulation of the the potato yield or the rice yield as per the environmental changes. So, this gives this indicates the model is responding to the change in environmental parameters. It may be carbon dioxide or the temperature. As per the increasing CO2, there is increasing biomass productions and increasing potato tuber formations, tuber productions, and the increasing temperature, there is a decreasing biomass and decreasing tuber productions. So, these are the informations has been you can create the experiment environmental, as I have shown you can create this, and you can do your own exercise. So, once you have the model with you, so create the environmental modification file and make the make this exercise, do this, and also you can try several permutation combinations that you can do this one and see the yield response, what I discussed the earlier rice class also, rice exercise. And this exercise, once you have got the data here, the data either the CO2 levels and the rise in temperatures, what you can do, you can create the response curve. You can see what is the response of the suppose rise in CO2 levels from, you can see the mean data here. Okay, you can come to the main window for this presentation. You see how the yield changes. So, as we have shown you can see how the yield changes from the carbon dioxide 0 ppm, 100 ppm, 20 ppm. This is the mean yield 64.37, 69.07, 70.19. Increasing CO2 levels, the main effect of CO2, what is the percentage change in the tuber yield, that you can calculate. So, yield increases around from 69.07 minus 64.37 by 64.37, the percentage yield change with the increasing 100 ppm CO2, that you can calculate here. Similarly, from increasing 200 ppm also, what is the percentage yield change from 64.37 to 70.19, that also you can calculate. You can see how the yield is increasing, the percentage of yield changes with the increasing CO2 by 100 ppm or the increasing CO2 by 200 ppm. Similarly, yield decline, the main effect of the temperature, the ambient condition, you can see the main effect 73.83 ton per hectare. With the 1 degree rise in temperature, yield decreases to 69.27, with 2 degree rise in temperature, yield decreases to 60.52. So, there is a huge reduction in yield, the rise in temperature 2 degree Celsius. So, you can see what the percentage change in yield with the increase in temperature 1 degree or 2 degree Celsius. Those type of interpretations you can do by having the data, creating the information or the knowledge creations, that gives understanding the response or the effect of CO2 and temperature to the in the rice production, any crop yield to rising CO2 temperature, what the changes we can notice with the rising CO2 and temperature, that will give a future predictions. Is the future climate changing, the CO2 and temperature, how the yield of particular crop is going to behave, that we can make an understanding from this simulation exercise. With this, I thank you all.